The Array of Things project is an urban project that has been deployed to Chicago and eventually will be deployed to other cities in the US. So the goal is to place nodes that include sensors, and the sensors will track uh, data, will collect data for track air quality, um, road conditions, traffic patterns, and other data. And the intention is to to enhance the quality of life for their population. So the data sources include there's 5 different data sources. One is projects, which include the city location, which right now is only Chicago. Nodes are the actual servers that contain the devices that have the sensors. And then the sensors within nodes, they collect the data, which include the air quality, pressure, temperature, etc. An observation data is basically stuff that's collected manually. And then the raw observations are the data that's collected by the sensors. So Array of Things has a website with a lot of documentation explaining what each of these data points are. And the sensor data sheets come from the Waggle site. Waggle is the vendor that provides the sensors. The solution to the project included 4 files. One of the things with this project had to sort out how to deal with the velocity of the change of data. So we needed to find a way to store the data in a database. So the first file was to actually create the database, and we use a MySQL server. The second file was actually to pull the data. So here we're collecting the data from the API, and then we're storing just the raw data into the database. We only collected the raw data, and we only stored the raw data because the raw data is what was used to that was the data that was changing. The other data didn't change as much. The third file was a schedule file. Basically, what that does is create a schedule task in Windows, and we could have done it manually, but I wanted to use a raw function, an R function, so I used the schedule R function. And basically, what that does is takes the script from that path, and it creates the my script. It creates the schedule script. It was a little tricky to get this done. We had to include the args within the schedule task for it to work. And last but not least, the last file is the actual Array of Things R&D, which we use to pull the data, display the data, and transform the data. Project in action. So the first part is basically just loading the libraries. Second section, we're retrieving the data and we're copying it to a list. And then we're using we're using JSON, the from JSON command, to push the list into a data frame. In the next step, we're converting the list to a data frame, and then we're just providing we're doing the names so we can look at all the columns that are in the data frame. In the transformation step, we try to separate the location information because the location information was comma delimited. So we want to separate the latitude and longitude into separate columns so that we can use later for the mapping. Next section, we're retrieving the data. So we're going to the database. So we're actually retrieving just the raw data that was collected every hour. And then the merge part, we're merging the data that we're pulling that is static with the data that was collected hourly. So with all that data we merged, we created a couple of plotly plots. So here we're actually displaying all the data by sensor. So as you can see in the plotly, we can double click on the actual sensors to get a little bit more detail of the data. So here this is a box plot and gives you all the box plot information, the median, the min, the maximum. So this is by sensor. And one of the things you can actually notice here with this setup is that you can see the type of of sensor, and you can see where there's anomalies, where one will be to the right or to the left of the median. So it's good to have it this way. There's one way to look at the data. Now, the second way we set up the plotly was to separate by address. So this will change depending on the time and whether the node or the sensors are active. So here we have 6 active nodes and 6 different locations. So here again, we're getting the min, maximum, and other statistical data per location. So if we wanted to just go directly to just one, we could drill down to the specific location where the node is located. Last but not least, so we used all that data to also map the information. So here we're pulling the static information, which includes the description, the address, and we're combining it with the latest reading with the timestamp, the sensor path, and then we're also taking some information from the hourly and then trying to add the number of samples that we've collected, standard deviations, and the average. So that's the content. Then we use the leaflet to actually build the map. And down here, we're actually using the content information that we added up here to display it on the map. So here's the map. This is basically pulling all the locations, and then in each map you can see the details. So this includes the details for the location, the last reading, the timestamp is actually current from today's date, and it's also GMT. So 1547. And right now it's 12:29 Eastern. So this is collected every 15 minutes. And as you can see, as you go to each of these lists, when you click each map location, you get specific information, and you can always drill down to specific streets if you wanted to. So that would be the mapping information. So basically we've collected the data and retrieved it and displayed it in plotly graphs and also in maps. So in conclusion, the project took updated API data from several sources, collected and transformed the data, merged and displayed the data in statistical box plots, and took geolocation to map the location of the device. The map displayed current readings and basic statistical information in the historical hourly collection information. Any questions?